B2 1. Like B2, we have also three parts.
No, sir. I think it's a different question.
Yeah, B2 1 till here we did. So far I can remember.
I only have B2.
Mhm. So what is written there? What is your last part? What is written there?
Using oil releases harmful gases which cause global warming.
Okay, okay, till there you did, right? So look, that one is B1, huh? B1 or
Yes,
A2.
sir.
So environmental, are you talking about B2 this one? Discuss one environmental consequences of using, yeah.
Yes, sir. I
So,
think we
so
did this one.
yeah, you completed this one. So we did not do question two.
Yes, we did question 2.
Yeah,
A
so
and B.
yeah, B till where we did. That one is my question. Like B1 we did, right? Question.
B1, yes, sir.
Then B2 part one also we did. Can you check what is
No, sir.
written?
I don't have B2.
Okay, so B1 you have, right? Calculate
Yes,
the
sir.
deceleration. So what is the value of deceleration?
0.01273.
Yeah, 0.01273. That means you can write 0.013, right? Meter per
Yes,
second
sir.
square. If you take in two significant figures, like
Sir, as this is deceleration, isn't the answer minus?
yeah, if it is written acceleration, then we will write minus with minus so that we can understand it is deceleration. If it is
Oh,
written
okay.
deceleration, already we understand it is minus. Okay,
Okay, sir.
that's why we don't write minus here. So what you got? 0.1, 0.0, right? 1, 2, 7, right?
Yes, sir.
Maria, yeah, you got this, right? So this one you can write 0.013, okay? If you write in two significant figures. Is it clear? So after 7, what is there? After 7, 0.127, then what is the digit? 1,
3, sir.
3, okay. So if it is 3, then we can write 0.0127, right? So you can write either
Yes, sir.
0.0127 or 0.013. Now, the next part, I welcome Mariam also. Mariam, hello Mariam.
Yes, sir.
Yeah, so you also have the same notes, right? B1 till B1, or you have something more? Hello.
Yes, sir.
Uh, so can you read this part? B2 1.
No, sir. Same thing.
Yeah, read it. Read it, please.
As the speed of the ship decreases, it decelerates or its deceleration changes. Suggest and explain how the deceleration changes.
Yeah, in our last class, at the last moment you got disconnected, right? Only Monica was there. That's why I think you missed this part. Yeah. So we are repeating it.
Yes, sir.
No problem. We are repeating it. So as the speed of the ship decreases, the deceleration changes. suggest and explain how the deceleration changes. So we understand one thing, like uh, if if we walk, then the air resistance we are getting. If we run, that time we are getting more air resistance, right? Isn't it?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. So it's related to speed. Like if your speed is more, then air resistance also increases. That means opposite force increases. The same thing is happening also in water. Like if any ship is going slower, then it feels or it faces less resistance from the water. But if the speed is more, then what happens? If the speed is more,
The
then
resistance
resistance from
increases.
the water will be also more, right?
Yes, sir.
Isn't it? So you look at the question now. As the speed of the ship decreases, that means if speed decreases, we have opposing force less, right? Isn't it?
Yes, sir.
If opposing force is less, we have deceleration also less, right?
Yes, sir.
Because the opposing force is working for deceleration. That's why we can say deceleration also decreased, isn't it? So
Yes, sir.
deceleration that changes, we have to make it more specific, that deceleration decreases, right? As the speed, how we'll write it, as the speed of the ship decreases, the opposing force or the resistive force from the water decreases. That's why deceleration also decreases. Okay, so I'm writing it. You also write. As the speed decreases, the resistive force from the water decreases. Also decreases. Hence, deceleration decreases as well. So you understood it, right? Hello?
Sir, deceleration decreases.
Yeah, deceleration also changes. That means if your opposite force or the resistive force decreases, deceleration also decreases, right? What is deceleration? Deceleration means slowing down, right?
Yes, sir.
So if the resistive force is decreasing, then slowing down also will become decreased, right? Isn't it?
Okay.
Have you understood?
Yes, sir.
Okay, very good. So if you understand, so Biraz Monica de Silva, she wrote something in the group. Let me check what she wrote.
Monica said she'll be late.
Okay, she is a little bit late. She is a little bit late. Okay. Mahi are joining. Mahi is saying I'm joining. Okay. Now we have, after this we have this graph. So Mariam, you read this part
Yes,
on
sir.
figure 2.2.
On figure 2.2, sketch a possible speed-time graph for the ship as it decelerates to rest.
Yeah. So uh, here we
Sir,
have,
do we need a graph paper for the graph, like for the figure?
no, you do not need any graph paper. Uh, you have this worksheet printed.
No, sir, not yet.
Not yet. Then one thing you can do, you can draw a similar graph. You give the number. It is B2. You see, it is B2.
Yes, sir.
Then
Yes, sir.
B2, 2. Okay. After B2, you
Okay,
give
sir.
2 this way. And you draw
Okay,
this
sir.
graph. Then whenever you get it printed, you take it there. Okay.
Yes,
It's
sir.
actually very much helpful and useful to get it printed so that you can get the questions and answer together. The whole thing, the holistic approach is there, right? You are getting
Yes, sir.
everything together. So it's better to have a printout. It will be your resource till O level. Okay. So
Yes, sir. I'm going
so
to get it
you
printed out.
please have a printout.
And
It will be
yes, sir.
awesome for you. Okay. Now uh, Mahi came. Yeah. So look here. We have here time in seconds and speed in meter per second, right? And the
Sorry,
speed,
sir, for joining late.
yeah, it's okay. Mahi, how was your last week function?
So it was good.
It was good, right? So
Yes, sir.
sometimes enjoying the function is good, right? So look here,
Yes, sir.
why in the graph it's given 9.7? Because the speed of the ship is at the beginning 9.7 meter per second, right? Isn't it?
Yes, sir.
So it's all about deceleration, and we have here look we have here deceleration of the ship calculated, isn't it? You got a
Yes,
value
sir.
of the
Zero point
deceleration,
one three.
yeah, 0.013 meter per second square. That one is the deceleration. So we have here this sketch that is 9.7 starting in the speed, and speed will decrease, right? So at least we understand that the shape of the graph, that it is decreasing, the line will decrease,
Yes, sir.
the graph is decreasing with time, right? As it is deceleration. And there is another information that we have to continue this graph till rest. That means when the speed will be zero, till there we will take the graph. Okay, is it clear?
Okay, sir.
So
Yes, sir.
two things. One thing is it is deceleration graph. That means the speed will decrease with time and it will be decreased to zero, right? The speed will decrease to zero.
0. Yes, sir.
That's why we have to draw the deceleration graph. Now, another point is there. Is it a constant deceleration or just non-uniform deceleration? That one also we can bring here in our graph. So here we have one idea. Look, as the speed of the ship decreases, its deceleration changes. So here in this part, we got the discussion that as the speed of the ship decreases, uh, we have less resistive force from water, right? Then deceleration also decreases, right? So
Yes, sir.
we have here deceleration. That deceleration will gradually decrease, right? That means our gradient of the graph will be, about the speed graph. If the gradient is, steeper, then the value of acceleration or deceleration is greater. If it is becoming flat, then value of deceleration or acceleration becomes less, or it's decreasing, right? So the shape of the graph will be, at the beginning it is steeper, but gradually it will decrease, right? The gradient will decrease. So Mahi and Monica was present in last class and she got this part, right, Monica? Hello, Monica.
Yes, sir.
Yeah, so that one I explained with them at the beginning, this part. And now for you, Mahi, we have the recording, right?
Yes,
And
sir.
in our last class also, you got the recording in our group also link in Google Classroom link. So you see, it's becoming flat, right? Deceleration decreases. Then it comes to 0, right? Is it clear? So, so if it is deceleration, that means speed will decrease, right? Then deceleration
Yes, sir.
decreases means it's becoming flat. Then it decelerates to rest means the speed will become 0 at the last. Finally, the deceleration will be going to in a way that speed will be 0, right? It rest means the ship is stopped, right? Isn't it?
Yes, sir.
So, and if it is stopped, that means speed is 0, right? So finally it reaches to speed 0. Is it clear now? Graph?
Yes, sir.
Yeah.
Yes, sir.
So and not only we are drawing the graph, uh, we are also writing some explanation so that you can remember it later on why we did this shape. It's not needed in exam to write. Only drawing the shape is enough. But for your notes, or you can remember easily, we are writing it. Okay. As deceleration decreases, gradient of the graph gradient of the graph also gradient of the graph also decreases. Okay. And finally touches the touches the time axis if touches the time axis, that means speed is 0, right? Speed becomes 0. Speed becomes 0. Finally touches the time axis, speed becomes 0. Okay, which means the ship reaches to rest. Okay, is it clear?
Yes, sir.
So this note you preserve for your understanding, right? It's not necessary to give it in the exam. Just drawing the graph is enough. Okay. So we are going to next part. Read read this part.
Um,
Read last part, this part.
Explain how the distance traveled by the ship may be determined from the speed time graph.
Okay, so this one is related to kinematics topic. There we will discuss when we'll go to kinematics. I don't know you got in other schools or in your previous studies institute, or previous teachers you taught you. So you get the idea from me that it's speed time graph, right? So if it's a speed time graph, if an object, for example, going for 2 seconds, 2 seconds, and here the speed is after 2 seconds, the speed is uh, 4. Okay, 4, and here is 2 seconds. Huh? Is it clear? Hello, are you understanding?
Yes, sir.
Okay, this is 1 second, and this is 2 seconds, and here time is measured in. I'm moving this time from here so that not make any confusion with you. Yeah. So here we go. Here is 2 seconds. I'll label it, and here again I'm moving this one. Okay. It is 4 seconds. Yeah, 4 meter per second. Then this one is 2. Okay. And this one is 1. Then this one is 2. Okay. And here it is uh, v. V is uh, velocity or speed. It is measured in meter per second. Then time, here time in x-axis, time is measured in seconds. Okay,
Sir, why did we take 4 meter per second?
it's like only to make you understand. I can take 5, I can take 6,
Oh, okay.
anything we can take. Like here it was 0, time was 0. then time is 1 second, 2 second. After 1 second, it reaches to 2 meter per second. Then after 2 seconds, it reaches to 4. Okay, then we are drawing the graph. Now, for example, the graph will be like this. Okay, the graph will be like this. Okay, so
So should we draw the graph?
yeah, you take these notes. It will make you understand later that how you got this answer. Huh? So if the question is asking you, there is given one question like this. Uh, what is the distance traveled? What is the distance traveled um, in 2 seconds? Okay, this is the question. Okay, now for this we will take area under the graph. Okay, area of triangle. Area of triangle is, what is the formula of area of triangle?
Half into base into height.
Yeah, so you are taking area under the graph. That means under this graph we'll get this triangle, right, in 2 seconds. So our half into base into height we are getting, we are having here half multiplied base multiplied height. So half multiplied base is how much? 2, right? 2. You also write
2,
the
sir.
unit. 2 seconds, right? Write also the unit, then you will see a magic. Okay, definitely you will get a magic. Okay, so 2 seconds. Then you write what is the height here? 4.
So the answer is 4.
Okay, wait. 4, then meter per second, right? If you
Yes,
say
sir.
4 only, it's not complete. Huh? You should say the unit also. You see here, seconds and second. This can be cut, right? One is denominator, another
4
one is,
meter per second square.
wait. What I'm saying, just try to get it. This seconds is numerator. Okay, 2 seconds. This second is numerator, and this second 4 meter per second, it is denominator, right? Isn't it? So they are multiplied condition, right? You know about the fractional multiplication, that if the denominator and the numerator is the same unit, we can cut that one, right? Isn't it? The way Mahi was saying, we are getting 4. How we are getting 4? This 2 and 2 can be cut, right? Half this 2 and this 2 can be cut, right? And it's coming 4 only. 4 ones are 4, isn't it? Hello? And what is the unit left here? Seconds cut. What is the unit left?
Meter.
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 Meter. Okay, That one is our magic. So meter is the unit of,
Distance.
okay, meter is the unit. Meter is the unit of distance. So from this expression, what can we understand? We can understand if we take area under the graph of speed time, that is giving us distance, right? Isn't it? So,
Yes, sir.
so it is the proof. The unit is giving us the proof that area under the speed time graph is giving us distance, right?
Yes, sir.
So right here, our answer will come now in this part. I think you know now what we have to write. Uh, they are saying explain how the distance traveled by the ship may be determined from the speed time graph. So what will write? Area under the speed time graph gives distance. Okay,
Yes, sir.
area under the speed time graph gives distance. I think though you did not go through topic to kinematics, I think from our discussion you understood uh, the answer of this question, right? From this explanation and discussion. So anyone, you have any questions on this? Hello?
No, sir.
Yeah.
No, sir.
Sir,
Maimuna,
understood.
you understood? Mariam,
Yes, sir.
Monica,
Yes, sir.
all are M, right? You see, Mahi is M, Monica is M, Mariam is M, and Maimuna is M. All are M, right?
Yes, sir.
We got
Yes,
four
sir.
M's. Then we have Al Farabi, isn't it? Farabi? Hello, Farabi. Farabi. Hello, Farabi. Where are you, Farabi? Farabi is hiding. He is not responding. Farabi, come out. Hello, Farabi. So we are done with this part. Then we are going to C, huh? Part C. Okay. So Monica, you read, please. C. Monica.
When the ship is traveling at a different speed, energy is being supplied to the engines at rate of 33. Wait, what's that?
Megajoule. This is megajoule. Huh? Mega means million. 10 to the power 6. So read megajoule per second. Yeah.
36%.
Hmm.
Number one, state a relationship that defines efficiency.
So you know the formula of efficiency, right?
Yes, sir.
What is the formula? Maimuna? Yeah.
Yes, sir.
What is the formula of efficiency? Mahi, Maimuna, Mariam, Monica?
Useful power
Sir,
by input power.
Yes. Yes. Very good. So output power.
Useful power output by total power input.
Yes. Very good. And we can also write energy. With energy also we can write, isn't it? We can write with the power, we can write also with the energy efficiency. So we can write useful power output divided by total power input, or we can write useful uh, output energy divided by total energy input. Is it clear? Hello?
Yes,
So,
sir.
so you write
So,
whatever you like, you can write with the energy or you can write with the power. Same thing, huh? You can write. Then last part,
so sir, we,
yeah. Have you written
so sir,
C1?
sir, in efficiency, should we write the meaning or the formula?
Formula. They are
Okay, sir.
saying relationship, right? Relationship. That means you can write the formula. Yeah. Then the last part, calculate the rate at which energy is wasted in the engines. So they are saying us efficiency. If you have efficiency, then you can find the output, right? Isn't it? Hello?
Yes, sir.
Useful output you can find. If you can get output, then you can subtract the output from input, then you will get the wasted energy. Is it clear?
Yes, sir.
So you do it. So if you get 33 megajoule per second, that is giving you the input, right? Because they are saying it is supplying, right? Energy is being supplied to the engines. So it is input. Then you multiply 0.36 with this input to get the output. After getting the output, that output you subtract from this, then you will get the wasted energy. Then join after 20 minutes. Salatul Esha break. Join after 20 minutes with your answer. Okay.
Okay,
Okay,
sir.
sir.
Thank you.